Thank you for being patient with me.
Zero-downtime deployment on Kubernetes. I'm Nicolas Frankel. I've been a developer for 20 years. Recently, I also became a developer advocate. And I wrote this talk because we live in interesting times, and I believe this is an interesting topic. The first question is, why should we do zero downtime? I mean, for a long time, we lived without zero downtime at all. When you wanted to deploy a new version of your application, you just switched the proxy to a static page. Then you did your deployment, you did file zone as necessary, and then you switch your proxy back on to the real site. I believe there are two reasons for that. The first reason is that the business wants it. And when they go to Google, when they go to Facebook, when they go to Amazon, the site is always up. And hence, if you present them with a static page, they won't understand the reason. And again, they will go to somebody else. The reason, so the idea, one of the oldest tricks in the book is to have BlueGreen deployment. With BlueGreen deployment, you have two complete different environments that mirror each other, and then in front you have a load balancer, a proxy, and your user are directed to one version of the site. In general, the initial version is 2. And then at some point, you want to deploy your new application, then you deploy everything on green. Meanwhile, your users continue to use the blue environment and everything is fine. After you have finished deployment, then you just push a big button, and then you direct your users to the new green environment. And it seems pretty magical. And even better, Kubernetes comes with the concept of rolling updates. So you have different pods, so it's not only one single server, but there are multiple pods. And then you just have several pods in a single deployment, and then you say, hey, I want to switch to a new version, and depending how you configure it, Kubernetes will roll out new versions of your code. And it seems to be pretty easy. And that's actually where most folks end. You have rolling updates in Kubernetes, everything is magic. But the problem is it doesn't address the biggest problem, and the biggest problem is states. And you have different kinds of states. In general, the main ones are sessions and databases. I believe that the state in session has been solved already for a long, long time through session replication. The state that is in session has already been addressed because actually when you got a load balancer and you've got several nodes and one of them might fail, even though you have session affinity, then you want your user to keep the state of their cards, for example. And for that reason, we invented session replication. So whenever you do a change in the session of a user, it's replicated throughout all of the nodes. That seems quite straightforward. But the problem is the database. Notice that in the previous diagram, I've shown you two different databases. The problem is what you have 2 different points to migrate your data. If you've got a couple of lines of data to migrate, that's fine. Got millions of lines of data to migrate, that's not so fine. So in general, you go to a variant of the BlueGreen deployment and you have a single database. And I will go through both options, single database and different database, and I will show you that in general, you probably want to go for option 2. So first, let's discuss option 1. We will keep the same databases, and the problem in that case is at some point, you will probably need to do a change of the schema. That means that your application needs to cope with 2 different versions of your database schema. And now comes the really hard part of Kubernetes is we've got this rolling upgrade, and now it's not only about having application pods, but we also have a DB pod, and it also needs to be upgraded at what point? Well, let's see. So imagine that we've got version 1 and version 2. We start rolling out the application to version 2, and we want the database also to handle version 2. But at this point, if we roll out version 2 of the database schema, the old pods, they won't work anymore, and it's an issue. So the idea is, okay, that's fine, that's easy. We will just deploy the latest version of the schema when all pods have done the migration, and it's pretty same approach. However, we forgot something. Like in general, when you do deployment, you don't expect that you need to roll back. But the probability of having to roll back because of some issues is not zero. And you always need to prepare for this occurrence. So if we do the same as before, and we just deploy the new version of the schema when all pods have been deployed, well, it works if there is no rollback. So here, version of 2.0 of the application can cope with schema 1.0. Now we can deploy the version 2.0 of database, but now we cannot roll back. At any point we need to roll back, it's not possible anymore. We cannot roll back the schema change because actually it's not compatible, and we cannot roll back a single one. So that means that every time we do a deployment, we must be sure that it will be completely correct. And that's not really how real life works, actually. Let's see how it works in practice. I have this e-commerce use case because I've worked in e-commerce before, and in general, it talks to people. So imagine I've designed my application very easily. I have a customer, and the customer has different cart lines, and every cart line has a single product. That's how I could have designed my first e-commerce shop. But now our business comes to us and saying, first, we have noticed that there are many people who put stuff in their carts, and in the end, they don't go to check out. So what we'd like to do is we keep track of the cards when they were last updated, and if they don't go to the checkout after 24 hours, we will send them a kind reminder that, hey, you've put this item and this item and this item in your cart, and you didn't buy, so perhaps you need a little incentive. So let's say, hey, you've got 20% of discount on your cart. This is something that a business might come up with. Now we've got the new schema designs. So we introduce this cart here, this cart table. So now a customer has a cart has multiple port lines, and this is not changed. And this is a breaking change. So if we want to deploy a new version of this application with a new version of the schema, it won't be possible. Well, it won't be possible directly. Actually, we can try to be smart and try to split this change. So instead of having one huge breaking change, as I've shown, we can have different small non-breaking change, or let's say changes that are compatible side by side. So 2 steps is not possible, but step by step it's possible to deploy and then roll back. Because again, rollback in generally is a good occurrence to keep in mind. There might be times that deployment won't be successful. So with this example in mind, here is something that I've come up with. The first step is, of course, we create the cards table, and the app still uses the old data model directly, the connection between a customer and its card lines. But now, every time we do change, then we get the cards and we add the card lines also to the card, not only to the customer. And however you do the replication, you trigger that. It can be regular triggers in the database, it can be the application. That's not important. The important part here is how you address this issue. So the old schema is still the source of truth, but you copy the data and the relationship to the new schema. Now at this point, if you need to roll back, everything is fine. You just add additional data, but the old schema is still the source of truth. The second step is you keep doing the same, but now your application uses the card as a source of truth. And every time you do a change on the card, you replicate it to the customer. So the application changes the source of truth, but if you need to go back in time to roll back, you can roll back to step 1. And because we've replicated everything, again, through triggers, through the application, whatever, then we still haven't lost any data. The third step is actually the problem. This works well, what I've shown you works well if we have data that is touched, if customers are actually using the cards. But imagine that we do the deployment, and during these deployments, there are lots of cards that are still there, and they won't be triggered, they won't be handled, they won't be replicated. So we need to move those cards to the new data model as well. And finally, we do some cleanup. And the issue there is that those cards, they can represent a lot of data. And that means we need to migrate data anyway. So if we keep the same database, there are lots of cons, in my opinion. The first is we need to do the steps decomposition. So for every breaking change, we need to find the right steps to decompose so that we can roll back. We can roll back a single step. We cannot roll back 2 steps at once. It won't be working at all. Then we need to plan, because all the things that we are doing right now, they impact different parts of the organizations. They impact the developers, because the developers need their application to be compatible with version 1 and version 2 of the schema. They impact DBAs, they impact DevOps. So everybody is impacted. And here I've shown you how it works with one single change. Now imagine if it worked, if you need to have different changes working in parallel, if you deploy multiple changes. Parallel, it will be a mess. Is that you will need to migrate, as I mentioned, you will need to migrate the data that was not touched. That's a lot of cons. So let's see the option 2, meaning we only have one line. We have two databases, two separate databases, and the issue was, hey, that's a lot of issues to migrate the data because we can have lots of data to migrate. But where we need to migrate of it anyway, so okay, we can cope with that. Well, we can cope with that by having something called change data capture. I will have a slide dedicated to it afterwards. And imagine if we have two different databases, then everybody is independent. That's not an issue. And of course, it can work with any deployment strategy. It can be generalized, it can be BlueGreen, can be anything. So about change data capture, this is what Wikipedia says about change data capture. The idea is, I won't read it to you, but the idea, you might be familiar with the idea of event sourcing. The idea behind event sourcing is that actually you will not store state, but you will store events. And then when you want to get the state, you will replay all the events to aggregate them to the final state. And because you might have lots and lots of events, then probably you will take some snapshots. So you will get the latest snapshot plus add the additional events and play them on top of the latest snapshots. That's really good. That's nice, but it needs, if you have a legacy application, then your application needs to redesign completely how it stores its state or its events, or call it however you want. With change data capture, it's the exact opposite. We keep our legacy application, we keep the storage of the real state, but every time we change the state, we will create an event out of it. And there are multiple implementations, of course. For example, in the past, if you have added a column in your table with a flag, with a last updated column, with whatever, and then you run a batch at regular interval that change this flag or this last updated column, and you have a conditional that say, hey, if I didn't before, then I do this, and then you change the flag, then this is the first step in change data capture. We will use something else in the demo, which is called Debezium, but the idea is still the same. So now, how does it translate it into a real deployment with Kubernetes? Imagine I still have my 3 pods, I still have my database, now everything is a pod. I have, this is the initial state, the original state. And now, step by step, how do we approach that? So the first thing is we will create, if it doesn't exist, the green database. And now the green database has a completely separate schema. It can be non-compatible. That's not an issue. We don't care that much. The next step is to actually create a data streaming that will capture the changes from whatever happens in the blue database, transform it according to the new schema, and push it to the new database. So here, this arrow just means that we are listening to changes and we will be writing. So here we are not writing, we are just like getting the data. The arrow means this component is the active one. The database doesn't do nothing. So now every time the users get on any pods and change something in their own schema, then every time the change will be pushed to the new database and transformed according to the new schema. Now we can start our rolling update, and the good thing is that the user that comes and gets on a new version of the pods will get to the green database, but since the green database is now up to date for this user with everything from the new database, then it's as if the user, well, hits the blue database. For the user, it's completely transparent. And so all pods are now upgraded like this in a rolling way, and now it works, but it's a bit more involved than just saying, hey, we have pods and we have a rolling upgrade, because all the underlying infrastructure that contains state needs also to be designed. At some point, all the pods will have migrated to version 2, so that actually there is no more data coming in, like no more data read by the forward job and return to the green database. So it might be time to stop the job. And then you can do whatever you want with the blue database. You can keep it for auditing. Here, what I didn't do, because I'm pretty lazy, I must admit, is I didn't add any backward job. So here I only add a forward job, but I could have also add a backward job, just again, in case you need to roll back. It's really good. So how do we implement it? Here is, I'm working for Hazelcast. So here is how we can do it with Hazelcast. This is just not the only way to do it, but this is the way I will do it. So Hazelcast is actually an in-memory technology that has both storage part. You can store stuff in memory, and you can also do data streaming. The idea is for data streaming, you have a couple of sources, one of them being database events. And here we will use CDC. And then we can do the transformation. You can also, it's fully distributed. So if you need like to scale it, it won't be an issue. And then we can like push the transform data from the database to database, another one, so from the green to the blue. And regarding session replication, we will store the session in memory. So in the demo, I will use the Spring integration, because you can just do like straightforward session replication, but I'm using a Spring application, so I'm using Spring Session, and Hazelcast is an implementation for Spring Session. And for change data capture, we will be using the Debizium. So here is a deployment diagram using UML. So I have my blue database, I have my green database. I will create the job that reads from the blue database and writes to the green database. And here I have a container that runs this job using several components. So first, the Jet API, the Hazelcast API, that under the cover uses the Debizium, and the Debizium itself under the cover uses the MySQL connector. The good thing with this approach is, imagine here you don't need to have MySQL. You might have Postgres, so you can also use it not only to deploy a new version of your application, keeping the exact same infrastructure, but you can upgrade your architecture using new components, as long as you've got the connector that is adapted. So I've talked a lot already, and I believe that it's worthless if I don't show you how it works in practice. So let's see how we can do that. Here I have created my application. As I mentioned, it's a Spring Boot application. I will be using like Spring Data GPA to access the database. I will be using Spring Web to have controllers for the pages, for the front end. I'm not a front end developer, so I will be using all technologies. So I will generate pages server side. As I mentioned, I'm using Spring Session and its Hazelcast implementation. And for it to work on Kubernetes, I just need to add this Hazelcast Kubernetes so that the networking port is taken care of. I've created this application. I've also, what I also did is I created, Docker container out of it. Using zip, because again, I'm pretty lazy, so I want everything to be taken care of. So now I can just call nvn com Google Cloud Tools double column zip Maven plugin, and it will create a Docker container. And this is has already been preloaded into my local daemon, because otherwise it would take too long. So here I just need to do the deployment. I've created such a deployment. It's here. So cube, and there is this application. So this is very simple. I've created a namespace. It has already been created. I've created a service, and I've created a deployment with 3 replicas, just as in my previous diagrams. And then I will deploy this Hazelcast shop 1.0 because I'm using Spring Boot. I have already created some liveness probe and readiness probe and startup probe. Here there is some configuration to override them from for Spring Boot. And let's do it. So here I will deploy this. I've aliased kubectl to k because again prefer laziness. And so I will do k apply-f infrastructure application cube slash application cube slash infrastructure. Whoops. It could work at sometimes. Application.yaml. And now we can watch how it gets deployed. Get pods W. So I already prepared the database because here the database is not that interesting. And it might take some time until all the pods are ready. So let's do some magic. Okay, this is looking good. So we can try. And let's say local hosts, and it's this port. you can see why I'm a developer and not a designer. So I didn't want it to be too complicated. So instead of having an authentication layer with Replication, actually we can just authenticate by choosing our user. So here we have user Joe. So we will log in into the shop. And let's say user Joe likes the Yeti mug. Now he has the Yeti mug. Now we can mock so that there is another user coming in, and of course their cart is completely empty. So we can add 2 t-shirts just like mine. Then we can do that the same with William, and we will at the end check that every user at after migration have everything in their cart. So I have a really good then like 4 stickers, so it will be easier to remember. So like 1, 2, 3, 4. We can go back to Joe and add some more stuff. And now imagine the other users, they don't do anything with their cart, but this user will just continue adding stuff to their cart. So we will like mock somebody who is interacting with the shop and mock people who are not interacting with the shop. Here you can see the version of the pod, of the deployed pod, and here you can say that you can see the pod's name. So this is asynchronous. So every time I do a change, I will need to refresh it explicitly to explicitly get this like normally. So here I will first need to deploy the new database. So let's deploy the new database. K apply F infrastructure Q. So it's green. K get W. So this is pretty quick. Just let's check the logs. K logs green -F. So we will wait a bit, but it is very fast. This is MySQL. You can use Postgres. You can use a lot of different databases, so it has worked. So now what I want to do is I want to deploy the streaming job. So every time I get a change from the green database to replicate through the blue database. So K apply, oops, apply, -F, infrastructure, Q, forward, here, K get W. And I will show you the code because this one is interesting actually. This is also very straightforward. I'm just using the Hazelcast API and its integration with Debezium and MySQL. And because I want to write to another database, in this case, I want to write to the green database, I need a driver, a dedicated driver. And the code is the following. It's very small. So here I have the main class. And as you can see, it's not a framework. Actually, I just need a main method that will be my entry points. And inside, we need to define the pipeline. And the pipeline is actually close to like English. You read from the Blue environment, and we will add the ingestion timestamp, and we will map the change report. This is what the object that we get every time there is a change. We will get its value because there is a header and there is a value. And then that we will like explode it to a map. And then we will get this map and change it to call parameters. And the call parameters is just the idea that we get important stuff like customer ID, product ID, and quantity, which basically makes up the stuff that is in the cards. And afterwards, we write to the green environment. And writing to the green environment is actually, again, very straightforward, a lot of configuration, and something that calls insert card line. And here, insert card line, if you are an old Java developer like me, you will remember this stuff. We are just like calling a prepare statement. So I already have the prepare statement, insert card line ready in my database, but of course you can do anything you want. And I will just pass the parameters that I've gotten. So customer ID, product ID, and quantity. So now it has been deployed. We'll just check the logs. Get logs report. And you see that not only we are listening to the changes that will happen, but we are also aware of the change that already happened before. So now on the green database, the cards are already filled in. And if we do -f to listen to new stuff, every time we will like interact with the cards, we will change, we will update the database, and in turn, we will be listening to the change here, customer ID 1, and that is Joe, product ID 1, that is the Yeti mug, and quantity 6. This is exactly what we have now. So now the green database is like in sync with the blue one. Every time there is a change, it is replicated. Now it's time to do the rolling updates. So let's do it. K apply -f infrastructure cube application 2. And the only difference with application 2 is that it has it has been designed to cope with the new schema. And meanwhile, I will try to interact with the application and to show you that it still is able to work. I need also to check get reports that it's actually deploying something. Just be aware, because it's sometimes it might be so transparent that as a demoer, I might not be aware of it. So depending on where you stand, it might be the most boring part or the most interesting part. Check normally, it should have already gotten some reports. So one of them, on which one I am, depends. It's this one. That's good. So let's try to refresh to check that it changed. Yes. So now it changed the ports, and it got me on a port that is still on version 1.0. So that's not what I wanted. I would have liked a version 2.0, but it's still working. And again, a bit of patience. So it's 26, it's terminating. Perhaps now I can refresh. Refreshing is just to check the port version. Yes, I'm on version 2.0, so I was not aware of it, and of course, I can still continue adding stuff. Now the migration has been done. And if we get back to check to see if they were upgraded correctly, yes, they had 2 items, and William has 3 hoodies. And of course, everyone should have 4 stickers. Yes, everything is working as expected. So I believe this is done. As I mentioned before, at this time, it could happen that there is an issue and we need to roll back. I didn't call the rollback, but the idea is just to have one single job. So you should first stop the forward job, and you should do a backward job. It will be just the exact mirror of the first one. And that brings us to the end of the session. So I hope that in this talk I showed you a couple of takeaways. That the first is a zero downtime is within your reach. I did this talk before, and I showed like the option 1 to have a single database. And given all the problems, I told people in the end, okay, you can do zero downtime, but probably it would be very complicated. It would be very expensive. Just check whether it's worth it or not. With this second approach, I believe this is much more manageable from an organizational point of view, from a technical point of view. And well, I think it's much easier to get zero downtime and to get the benefits, and you don't need to invest that much. There are 2 things to cope with when you are deploying a new version of the application, and they are both related to states. The first one is sessions, and here you saw that I didn't even show you the session because it's all taken care of by configuration. There is no code necessary, again, because this is an old recipe. Session replication has been with us for a long time. And the second is database state. This is much harder to cope with, but I hope that I show you that with change data capture and data streaming, you can achieve this. Thanks a lot for attention. You can read my blog, you can follow me on Twitter. If you're interested about the code is readily available on Twitter. So if you want to see the whole of the code, which I couldn't do in such a small time frame, well, you are welcome. And yeah, if you have issues, just open to request or whatever to improve it. If I got you interested in Hazelcast, again, though this talk is not about Hazelcast, join our Slack or get some free training. Again, have a very good day and see you soon.
Frank, thank you Nicolas, thank you so much for your patience with everything and the start of the video, and for all those who are watching, thank you as well. If there's any questions, Nicolas, I think you can see them in the chat or you can ask in Q&A. But we're going to go over by a few minutes to make up for the delay. So if anybody has questions, or if there's anything that you would like to add to your presentation that maybe you didn't get around to, or you thought, oh, I should have said whatever, but didn't get a chance to do, we do have about 10 minutes or so. So anything you'd like to add to your presentation?
I'm not really sure. I mean, the scope, I try to define the scope. I try to drill down into like the scope. So I think that right now, if it's clear, that's super great. If it's not clear, and now, I mean, that's very hard for me, because for me in my head, it's super clear. But of course, I don't know if I conveyed the right messages the right way. So if it's the time, if somebody has a question, something that's not clear, or perhaps they have a similar use case, they want to know how to do it, then that's the right time. I mean, that's the point of Q&A, to have some interaction, not to sit and just watch a screen.
Yeah, I don't see any questions. Other than, people are asking about the start of the video and things like that, about the talk itself, just about my logistics. And for those who joined and thought, what is going on? I didn't know I was supposed to play the video. So we had a little bit of a mix up this morning, but we did great. Nicolas, just because there aren't any questions and we do have a few minutes, and I am getting the opportunity to meet you for the first time. I've heard your name in different circles in the Kubernetes world and stuff, but can you tell me and those who are watching that a little bit about, because I think everybody has a story about how you got to where you are today. What excites you? And I know you've got your book and all that, but what excites you about Kubernetes and the changes that we've seen in the last, less than 10 years really in this space? Like what excites you about it the most?
That's a huge question. Well, like largely the world is becoming, we've got more options. Like before, we only ran our application on our own infrastructure. And so people started to say, hey, but that's a waste. Perhaps we should mutualize infrastructure, and then came the cloud providers. And then every cloud had their own like services. It was hard to learn. And then perhaps somebody said, hey, that's a waste of skills. Like everybody has their wall garden. Perhaps there should be something that makes it easier if you want to move from cloud to clouds. And yeah, we've got more and more option every day. And I think that's the exciting part. Like you need to learn a lot every day, which I've been 2 decades in IT. I still like it, especially because, yeah, you cannot just rest and say, oh, I will enjoy life now. You will always need to like, oh, what's this new stuff? Okay, does it apply to my use case? What are the pros? What are the cons? Okay, I put it in my tool belt. That's one more tool. And then afterwards, when you've got all the tools around your tool belt, you've got a problem. You can like check which one is the most adapted. I think that's really, really great. And it doesn't apply only to Kubernetes. It applies to programming languages, to applies to like approaches, imperative versus reactive, like what's the best front end. All this stuff is like super interesting in my opinion.
I think it's the same. I share your same opinion, that I just think it's all just the way it's all coming together. And I don't know how long you've been around this space, but seeing where it was like in the open source space in the early 90s to where it is today, it is like this huge evolution of not just the kernel itself and not just the operating system, but all the other layers now that are now becoming open that weren't before. And like if you look at a data center and you think about all the components of a rack, for example, there is not a single component of the rack that's not open now. In these days, whether it's the hardware when you look at open compute, or whether it's the software when you look at all the open source elements. So to see this evolution and the part that you're playing in this evolution is pretty exciting. So do you if you look back over that time frame, what do you think stands out the most in the evolution of open source the way we are today?
The only constant is change. It changes all the time. So it's hard to say like, hey, this is really important. Actually, my experience has taught me that everything is a cycle. So when I started working, we had the server, and the server generated the pages, and then the business logic one on the server, and then it started to move from the server to the clients. And that looked a lot like client server before. And again, now it's starting again to move from the client to the server, just like the mainframe. And it's just like we are always reinventing the wheel and changing our ways. But like again, after like perhaps 10 years, you start to spot there is a cycle.
Yeah.
And the old becomes the new.
Exactly. And speaking of that, like when you think about, you often tell people that no matter, pick any open source project out there, pick any open source, anything that's out there, there's new people coming every single day. And when you look at your experience and people look at you and they're like, oh my gosh, like, you know, I'm intimidated by skills or like whatever it happens to be, because, you know, we all start somewhere. What is that one piece of advice that you would give someone who's new to Kubernetes? Like, what would you, that thing that maybe you wish somebody would have told you? And it's a little bit different when you're on the front end of it and you've been around since the beginning, but like, think about being back in that new user seat for a minute.
I mean, it's hard for me. What can I tell? I'm a learner by doing, so that's how I understand things. So yeah, try it, play with it. Like at some point, for example, I got interested in operators. Everybody was saying, "Hey, let's have an operator. Let's use an operator." And I thought, "Wow, that sounds really, really complex." And actually, I created an operator. I made a talk of it. And so that's to explain to people, hey, like an operator is just a control loop. That's a controller. And actually, it's a control loop that works on custom resource definition. And that's all. So, and yeah, so don't be afraid and like try by yourself. The documentation sometimes is huge. You don't need to know every details. Most documentation, I must be honest, is just like either like too huge, or I mean, there are ways to organize the documentation. And sometimes, yeah, the Kubernetes documentation is like one big block and it's very hard to get in. So just like take one piece and take one slice and try to explore that slice, and take another slice, try to explore that slice. There are a lot of slices that I don't know about Kubernetes, and that's fine. I mean, as long as you are like T-shaped, like you've got big picture about a lot of different things and some slices on understanding, that's perfectly fine. And if you want to dive deeper, of course, nothing prevents you. If you know enough, and that's perfect, choose another subject and yeah, learn more.
I like that advice because I tell people nobody's born with this information. You know, we don't all come into the world knowing these technical things because technology changes. Like you say, the more it changes, the more it stays the same. It's a big cycle. So when people have the opportunity to get little snippets of wisdom from like you and others on the track today, I like to at least give you the opportunity to encourage this new set of users that are coming up. And you said something very important and very powerful, which is when you learn something, you share it. And that seems to be, you know, exactly what you've done over your career in this space is learn and share, be it through webinars like this or your book or whatever, like those type of things. And so I like the fact that everyone who's here today that I've talked to over the past few years with not only Community Leadership Summit, but with All Things Open, that's their number one piece of advice is learn it and share it. Yeah, and even if you fail, share the lessons there too. I think it was in the early, like the pre-release version of the open source way back in the day that Karsten Wade was working on. And in there, it said, if you fail, take notes. And you know, it seems to be in line with everything that you said today. And I'm sure All Things Open, when they share the recording, they're going to share the clean version, the big screen version and all of that. So again, I apologize for this morning. I apologize to those who are watching, and we'll be back at about 2 o'clock. And Nicolas, again, thank you so much. And I'm honored that I got the opportunity to meet you today. And so maybe our paths will cross at other open source events as the world opens back up. So thank you.
I hope next year I will be able, to fly. Like normally I should fly to the US in December already, not at your conference, but to another one. So yeah, I hope that next year the world will open again and I will be able to meet people. Until that time, stay safe.
Yep. So we'll talk soon, and I'm sure the ATO folks will be in touch with you about when your video will be up and all of that. So thank you so much.